Okay, so for D, we draw the tie line, right? And when we draw the tie line, and then we look up. Okay, for the far D, we draw a tie line and we move down here, right? And we see that T alpha is 13 or 14, right? So this part, and this part, these are done, right? So Omar, do you understand the problem?
Yes, yes, yes. I understand it now.
What is
Very clear.
it easy or difficult?
Moderate.
But you know, you have to look up the graphs, and you should know. I explained this in lectures that how can you look at this graph. For example, let me go back to this and help you understand this better, right?
Yes, please.
Okay, so this is a kind of graph, right? And one thing for sure that many of the questions are possible, right?
Yes.
For example, your professor can ask about this, that I start from 400 degrees centigrade, right? And I I heat up this alloy, right? And like this upward, I go at the composition, right? Let's say it is 85, right? So sorry, let me change my color to your favorite color. It is blue. Okay. So from 85, right, I start my cooling from this 400 degrees centigrade, right? And I move above. So at this point, you will see that the beta plus liquid, right? So from alpha plus beta, I move directly to beta plus liquid. And then I move directly at this point to liquid. So first of all, you should keep a track of these quantities, right? Say that I'm entering from a region of alpha plus beta to beta plus liquid and then to liquid, right? And one more thing that you people should know, that you should read the composition, right?
Yes.
So for instance, if your professor has asked in this question that what is the weight percent of this liquid, right? So how will you determine the weight percent? Can you determine it?
By the formula.
Okay. Okay, so let's do the weight percent. If, for instance, if it is asked in your paper, right? So you should be able to determine the weight percent of the liquid, right?
Yes.
Okay, so at this point, what was the CL? CL was 61.9, right? Okay, so CL is 61.
Yes, 60.9.
Okay, so this was CL. CL was 61.9. And what was this point? This was 30%, right? So it was 30 weight percent. And what is C alpha? It is written here. It is 18.3, right? And C alpha is 18.3. And it has been asked that find the weight composition of this liquid, weight percent. So what is W of
The
L?
formula is the WL equal S over R plus S.
What is S and what is R?
It is C what is called C dot plus sorry minus.
Please. You know, this is you are memorizing things. So please don't memorize. This is a conceptual question, right?
Oh, okay.
Okay. So when you find the composition of liquid, right? So when you are given with the liquid, Hamza, are you listening?
Yes, here.
Okay. So when you are asked about the composition of liquid, right? Then you will see the opposite side, right? So you will found this length. What is this length? What is this length? It is simply 30 minus 18.3, right?
Yeah, right.
So 30 minus 18.3. Okay, so this is basically I call this I can name it A, I can name it B, whatever, right?
Yeah.
And divide by this whole length. This whole length is 61.9 minus 18.3. So this will give you the weight composition of the liquid. Similarly, if you want to find the weight percent of alpha, then it is 1 minus weight percent of liquid, because there are only two phases, right? And it will give you the weight percent of
Yeah.
the weight percent of the SN, right? In the liquid.
Yeah.
Okay, so Umar, do you understand what I'm saying?
Yes, yes.
Okay, so don't rely only on the formula. If you know these things, if you know about the moment, if you know how the formula was derived, then you can explain all these in your own words, right? So the basic technique, all of my students, they gain a very good power from my lectures, that they clear their concepts, right?
Yes.
Okay, so in engineering student, it is the responsibility of our engineers that we should make our world more better, right? So when you know these type of things, so it will help you in the manufacturing process, which are the courses which you will study in the later part of your semesters, right?
Yes, we will take it in the seventh semester.
Yes,
And
yes.
the seventh, yeah.
Okay, so yeah, so I am telling you that these things are the foundation for your incoming courses, right?
Yes.
Okay, now let me explain to you. Your recording is on, right?
Yeah. Now okay.
Okay, so it says that for a copper silver alloy of composition 25 weight percent, right, and Ag 75 weight percent of copper at 775 rate. Do the following: determine the mass fraction of alpha and beta phases. Determine the mass fraction of primary alpha and the eutectic micro constituents, right? And determine the mass fraction of the eutectic alpha, right? So let me, do you have the diagram of this question?
I sent you the book. You can see it.
This, right?
Okay, okay. No problem.
Okay, so now it says that I think it's a very good problem, right? Okay, so it says that for a copper silver alloy of composition 25 weight percent Ag, 75 weight percent copper, right? So first of all, you should look at the x-axis. So in the x-axis, what is this? Silver,
WT percent, yes.
silver, Ag, right? Ag,
Yes.
Ag is silver, Cu is copper. So this is the CuAg alloy. And the page diagram part, this is drawn here. And it says that 75% copper and 25% Ag. So you will, this is 30 and this is 25, right? So our point of interest is here, 25. So this is our point. Okay, so and say temperature is 775. Okay, so this is 700, right?
But it showed in Kelvin, right?
This is degree centigrade.
Okay.
And also there is degree centigrade, right? Okay, so 775 degrees centigrade. So what do you think where it will be? Okay, so you see the eutectic temperature is how much?
779.
779. So it means that we are just below this eutectic line, right? So
Yeah.
we are here. So this is our point of concern. Yeah, right?
Right.
So first of all, when you are given with the temperature and the composition, then you should be able to look at this point. So when you look at this point, then you should look at the pictures. Okay, so now it said that determine the mass friction of alpha and beta, right?
Right.
Okay, so now where should I okay, so you will draw a tie line here, right? And you will draw one tie line here connecting the beta, right?
Okay.
So this point will give you C of alpha, and this point will give you C of beta, right?
Okay.
Okay, so mass friction of alpha and beta you have known, right? Okay, so now part B is very interesting. It says that determine the mass friction of primary alpha and eutectic microconstituents. So how will you do that?
No, but just to be clear, what's the answer for number A?
For number A, you will note down here, right down here, and this is 10, right? And almost it is above the middle, right? So it is not in the middle, so it will give you almost 7, right?
Oh, okay.
Okay, 1 minute. I'm getting a call from my hello, hello. Okay, so this is our last question. Said that for copper 25% silver, 75% copper, 75 degrees centigrade. So this is 25% silver, right? You will note down here, and you will go at this is 779, so 775 will approximately be here, right? And you will draw a tie line for the part A, and you will draw a tie line again here, right? And when you draw a tie line, then you will note down the C of alpha, and okay, so this comes out to be almost 8, and if you draw down here, right? Okay, so this comes out to be almost it is 90 and it is almost 92, right? So it comes out to be 92. And now when I want to determine the weight percent of alpha, then it is similarly similar to like this, where alpha is scared, so alpha will be this is alpha, so I will take the opposite side, which will be 92 minus this 25 divided by this whole length. Whole length is 92 minus 8. So it almost comes out to be 0.9 0.794, right? And W of beta will be similarly 1 minus 0.794. Okay, so part A, this is the answer for part A, right? And it is comes out to be 0.206, right? Okay, so now I want to determine the mass fraction of the primary alpha and the eutectic microconstituents. So now if you want to determine the mass fraction of primary alpha and the eutectic microconstituents, right? So you have to analyze with the lever rule, and you should we draw the tie line here, and we said that the maximum solubility of Ag is in the alpha phase, right? It is 8%, and the maximum solubility in the beta is 91.8, right? And the eutectic composition it is 71.9, right? It is written here. So the primary alpha will be W of primary is equal to uh, this this line. We will consider this line, right? This is our 25 line, and this is 8 line, and this 71.9. So it will give you the for the primary alpha, it will give you 71.9 minus 25 divided by 71.9 minus 8, right? So for primary alpha, as I already told you that we will see the opposite side. So this is alpha, so for primary alpha, we will see that this. So it comes out to be 0.734. Now when I want to determine for the micro constituents, right? So for the micro constituent, applying the similar law, and then we can see that W of micro constituents is equal to, since micro constituents on this side, right? So you will consider this, and it will give you the 25 minus 8 divided by 91.92 minus 8. So it will give you, sorry, 71. 25 minus 8 divided by 71.9 minus 8, which will give you the 0.266, right? Okay, and for the last part, it said determine the mass fraction of the eutectic alpha, right? So how much is the eutectic alpha? So for the eutectic alpha, you know the primary alpha, right? And we know the primary alpha, the total alpha. So alpha is equal to alpha primary plus alpha this much eutectic. So we want to find alpha eutectic. So alpha eutectic is alpha minus alpha primary, and alpha comes out to be 0.794 minus 0.734, which is above, right? So okay, so alpha eutectic will comes out to be 0.061, right? So this is our answer for the part C. Okay, thank you. See you next time. Allah Hafiz.